Hi, welcome to TDCat.com. We're in Audition again today, and we're going to see whether you can hear the squeal of an old CRT television. I was watching a video on YouTube today from one of the people I subscribe to, which is Julian Ilett. He does all sorts of stuff with electronics and things like that. And he was using an old 80s computer monitor for something he was doing. And someone commented saying they could hear the squeal of it in YouTube. And it just sort of reminded me that you don't hear that anymore, do you? The old squeal of a television. The very high-pitched noise that you associate with a television is actually caused by the transformer that horizontally scans the electron beam across the screen. And you can work out really, really easily what frequency that tone, the squeal is actually at, because PAL in the UK is at 625 lines. Electricity is at 50 hertz in the UK, which gives you a figure of 31,200, is that right? 50 multiplied by 625 is 31,250. But of course, it's interlaced, so it's not scanning all 625 lines each time. It's doing half of that, so divide by 2, and that gives you 15,625 hertz, so 15.625 kilohertz. That is the frequency of a squeal on a television. So I'm in Audition, and I'm just going to do this without. I should use a frequency generator for this, but all I've got is Audition, so let's just see whether it works or not. So we're going to go to Generate, and we're going to do some tones. And in here, we don't want to enable sweep frequencies because we don't need a start and an end because we're not going to change the frequency, but we're going to set our base frequency to 15,625. And then we only need one frequency component here because we're not doing any kind of additional multiples of that frequency. We just want that one, which means at a multiple of 1, it gives us 15,625, and we'll do an amplitude of minus 10 dB. And if we generate 10 seconds of tone, that will be enough. I think there's 10 seconds, is it? Duration 10 seconds, there we go. So there we go, there's our tone. If we zoom in on this is a 44.1 kilohertz WAV file, so there aren't actually that many sample points as we zoom right into the wave itself. But we can see on the frequency analysis that the tone is sat there at 15.6 kilohertz. And we need this set to a fairly high FFT size because otherwise we don't really get that sort of tight accuracy around what the point of the frequency is. So that gives us nice accuracy there. So what I'm going to do now is turn off the mic. I'm going to bring in my mixer here, and I'm going to fade the mic and fade the processor down because I just want you to be able to listen to Audition. So I'll do that now. I'll bring down the mic processor, and you can listen to the tone and tell me whether you can hear it or not. So you could hear the start, possibly a click at the start and the end. I don't know if that's kind of some sort of offset or something like that causes it, but you can't really avoid that. So were you able to hear that? I've got fairly good headphones on, and I can't hear a thing anymore. My ears are just not good enough anymore. It's a bit disappointing. It's only just over 15K and I can't hear it. How rubbish is that? But I don't know whether YouTube will accurately create it. So let's try it again. I'll just take the mixer down again and give you another chance to hear that. So there we are. That's all I was trying to do today. Just see whether or not YouTube can generate that tone accurately, whether or not the system here can generate the tone accurately, whether I can hear it or whether anyone else can hear it. Because it's something I used to always notice when I was a kid, that noise on the television, and that post on Julian's video, and also the post that I did on the website. I'll link to the video here on lossless versus lossy audio. We were talking about kind of high frequencies, do they matter, can you hear them, and all that. So this is just a look at whether you can hear that tone or not. Let me know in the comments below. And that's it for today. I will catch you soon.